Section 2 is an introduction to Code Composer Studio version 5.1. Code Composer is an integrated development environment, or IDE, that combines the editing, debugging, and analysis tools into a single package. It's based on the Eclipse open source tool. Before you can write code for the MSP430, you need to get acquainted with the tool that you'll be using. The MSP430 is also supported by IAR's Workbench tool, which is a fine IDE. But the labs are all written to use Code Composer, so let's get started with that. Code Composer Studio is an integrated development environment for TI embedded processors. What do we mean by integrated? It means it includes the debugger, the compiler, the editor, the simulator, any support for an operating system that you might have, all of those things together in a single tool that you can use to program the device and program it onto the device. Our integrated development environment, or IDE, is built on the Eclipse open source software framework. We have extended that with our code development team to support the exact device capabilities of the MSP430 line. Of course, Code Composer Studio supports the entire series of processors that I showed you earlier for Texas Instruments. Code Composer Studio version 5, in our case version 5.1, is based on an off-the-shelf version of Eclipse. In 5.1, that's version 3.7. Future versions of Code Composer are going to use unmodified versions of Eclipse. So we are contributing directly to the open source community. That means you're going to be able to drop in a new version of Eclipse. You're going to be dropping Eclipse plugins from other vendors, or take TI tools and drop them into an existing Eclipse environment. As a user, you can take advantage of all the latest improvements that are being done to Eclipse. You can also integrate additional tools. If you're working with operating system application development tools like for Linux, for Android, if you're doing additional code analysis, source control type stuff, all of those integrate directly into the tool. We will be having Linux support soon, and by the time you are listening to this, we may have it already. We have brought the price down on this. If you download it from online, it's $445. Or if you get a CD, it's $495. Code Composer Studio supports two user interface modes. In the past, some common complaints of Eclipse and Code Composer were that the tools and the menus were too complex and there was too many options in them. So to fix that, we've gone ahead and created a simple mode. So by default, Code Composer opens in this simple or basic mode. It's a simplified user interface with far fewer menu items and toolbar buttons available to you. It comes automatically with a TI-supplied edit and debug perspective that we'll be taking a look at in a minute. You can switch to advanced mode if you like. That uses the default Eclipse perspectives, very similar to what existed before in Code Composer Studio version 4.x. That's recommended for users who will be integrating other Eclipse-based tools into Code Composer. It's certainly possible to switch modes. The user can decide that they're ready to move from simple to advanced mode or vice versa whenever you like. In my experience with it so far, I've had plenty of good luck by just using Code Composer in simple mode. Common tasks in Code Composer have been significantly simplified. Something like creating new projects. It's now very simple to create a new project for a device using templates if you like, with a single page dialog. The build options previously were difficult to use for some users, and many found it overwhelming. There were literally thousands of choices that you could make. Now updates to the options are delivered via compiler releases and not dependent on Code Composer Studio updates. You can decide when to apply those compiler updates or releases to your design if you want to do it. If you want to make your projects portable, you want to be able to share them with somebody else. It's now much easier for users to share projects, including working with version control with other folks. Setting up linked resources into your projects where you want to bring in a library from someplace or or a header file from someplace and you want to link it into your project rather than drop it into your project. Setting those up is much simpler and is a joy to work with. To understand Eclipse workspaces and projects, when you work with Code Composer Studio and Eclipse, you want to create a workspace to work in. A workspace will contain your settings and preferences that you use for Eclipse, as well as links to your projects, not your projects themselves. So here you can see we have projects 1, 2, and 3 in there, all the settings and preferences, where we put the windows, how many different perspectives that we have. This way you can delete projects from your workspace by deleting the links, not the files themselves. So each one of those projects can contain source files, header files, libraries files, all the build and tool settings for that individual project. So it contains those as well as your input files. When you can delete a file from the workspace. That will delete the link, not the files themselves. So you can see we have links to the source files like the code and the data, the header files, the declarations and the defines, the library files, the codes and data, each one of those coming into a project, the projects being linked into the workspace. You can have as many workspaces as you like, with as many different projects as you like in each one of those workspaces. You can even have one project as the base for your code inside all your different workspaces. So there's a lot of flexibility in this, and it's fairly simple to work with once you get started. I mentioned earlier that creating a project was straightforward and easy. Here's the project wizard, a single page dialog. We give it the project name, tell it what type of output we're going to have. In this case, it's executable rather than something like a library. We can select the location for the project, the family, where it says device. We select MSP430, ARM, Satara, whatever family that we're using. In our case, it's the MSP430. For the variant, you can simply type your device. In our case, we can type 2253, and it will come up with the variant that we select. So we make sure that the code that we're writing complies with the size restrictions that we have for the part. We can specify what the connection here is to our emulator. In this case, we could have said it's the simulator, but in this case, it's the USB connection to our LaunchPad. Then down where it says project templates, you say, and the empty projects, you can pick a regular C empty project, an assembly only. There's other examples that we'll be able to work with later. If you wanted to, you could have clicked next and made additional selections, but in our case, we just click finish. So the single page wizard is all you need for the majority of users. The debugger setup is included in here. If a specific device is selected, then the user chooses a connection, and then there is a CCXML file that's created that makes the connection, the target connection to this. It's very simple by default. The compiler version, the endianness, all that stuff is under the advanced settings. The things that you generally don't touch, all that is in the background. Adding files to projects is very straightforward and simple. From the Project Explorer, you can right-click on the project, or you can go to the at the menu bar. You select Add Files to Project. In Code Composer 5.x, you can select as many as you like, say Open, and then you can determine how those files are going to be imported into the project. Do you want to copy those files into your workspace? Or more likely, do you want to link to those files? You can create a link to those relative to whatever the project location is. That way you're going to be able to create a portable project that you'll be able to send to somebody else, and they'll be able to get working without having a huge number of unfound files that they have to relocate everything in their system to match your system. Add files to the project allows the user to control how the file is added to the project. Linking those files using built-in macros allows you to easily create very portable projects. In addition to Texas Instruments Code Composer Studio, IAR has a tool called Kickstart that has a 4K compiler code size limit with it. This is a free tool that goes up to 4K. If you want to go above that, you have to pay the license fee for their full version of the tool. This supports all MSP430 variants, has the assembler, the linker, the editor, the debugger, the compiler inside of it. The IAR tools are really the gold standard of MSP430 compilers and tools. In Lab 2, you'll start using Code Composer Studio. Don't get bogged down trying to understand the code now. You'll get to that later. Concentrate on the tool itself. In Step 1 of Lab 2, start Code Composer Studio by double-clicking the icon on the desktop or selecting it from the Windows Start menu. When Code Composer loads, a dialog box will prompt you for the location of a workspace folder. Browse to C:/MSP430 LaunchPad/workspace. And don't check the Use This as Default checkbox. We really want to know where our workspace is every time we start Code Composer. When you've done that, go ahead and click OK. This workspace folder contains all the Code Composer custom settings, which includes project settings and views when Code Composer is closed, so that the same projects and settings will be available when Code Composer is opened again. It also contains a list of your current projects. The workspace is saved automatically when Code Composer Studio is closed. Now, if you're starting Code Composer for the first time, you will start up with a license setup wizard as seen in Step 2. Ours is not going to do that because ours is licensed. If you're starting with, if you're only using the MSP430, you can use the code size limited version. If you're using something else, you'd have to go ahead and either activate or use the free license. On the value line series of parts, the 16K code size limited is just fine because none of the parts have more than 16K. In Step 3, you may see the TI Resource Explorer open in Code Composer. The Resource Explorer provides an easy access to code examples, support, and Grace. We'll cover Grace in a later module. Go ahead and click on the X in the tab to close the Resource Explorer. So at this point, you should see an empty Code Composer Studio workbench. The term workbench refers to the desktop development environment. Go ahead and maximize Code Composer to fill your screen. So the workspace, or rather the workbench, opens in the CCS Edit view. And you can see CCS Edit in the upper right. If you grab the left-hand side of the tab and pull it to the left, you'll be able to see both of the tabs. There we go. Okay. We'll get the other tab when we start the first CCS debug. The tab in the upper right corner is what switches you back and forth between perspectives. A perspective defines the initial layout views of the workbench windows, toolbars, and menus, which are appropriate for the specific tasks that you're doing. Like here, we're doing code development and debugging. This minimizes the clutter on the user interface. The CCS Edit perspective is used to create or build Code Composer C-type workspace projects. A CCS debug perspective will automatically be enabled when the debug session is started. This perspective is used for debugging your projects. You can customize this and save as many as you like. In Step 5, we're going to create a new project. A project contains all the files you're going to need to develop an executable output file, which can be run on the MSP430 hardware. To create a new project, click File, New, CCS Project. Go ahead and make the selections below. Your dialog may look slightly different than this one, and if you're using an earlier version of the board, like the MSP430 G2231, make sure you make the appropriate choices for that part. Make sure you click Empty Project at the bottom and click Finish. So you can see we're picking Temperature Sense Demo. The capitalization honestly doesn't matter there. Make sure you pick the location to be in one of the folders that I've already set up for you, the MSP430 LaunchPad Labs, Lab 2, Project under TS, or Project-TS. In the family, make sure that you pick MSP430. If you only have the MSP430 installed, that's the only one that'll show up. In the left-hand window where it says variant, you can just type 2553, and that will bring up the 2553 directly. Make sure you select Empty Project in the Project Templates window and click Finish. In step 6, Code Composer will add the named project to your workspace and display it in the Project Explorer pane. That's the one on the left. For your convenience, it's also going to add a file called main.c and open it for editing. Click on the temperature sense demo in the Project Explorer pane to make the project active, and you can see ours is already active. Go ahead and click on the plus to the left of temperature sense demo so we can see what's inside of here. So next we're going to add code to main.c. Rather than create a new program, because we're not concerned with the code here, we're going to use the original source code that was pre-programmed into the MSP430 device. That was the program that we ran in Lab 1. Click on File, Open File, and navigate to C:\MSP430 LaunchPad, Labs, Lab 2, and Files. Open the temperature sense demo.txt file, copy and paste its contents into main.c. Make sure that you erase the original contents of main.c, then close the temperature sense demo text file. We're not going to need that again. Near the top of the file, note the statement #include MSP430G2553.h. If you're using an earlier revision of the board with the other part, the 2231, make sure you go ahead and change this statement to include MSP430G2231 instead. Ours is using the 2553, so we're going to stick with that. Go ahead and save main.c by clicking on the Save button in the upper left on your menu bar. In step 8, Code Composer can automatically save modified source files, build the program, open the debug perspective view, connect and download to the target in your flash device. Then run the program to the beginning of the main function. It does all that by you clicking on the debug button. So go ahead and click on the debug button there. You'll notice the project building in the console window at the bottom of the screen. After a few moments, we'll swap over to the Code Composer debug view, CCS debug. Notice the debug icon in the upper right-hand corner indicating, or rather the tab, indicating that we're now in the debug view. Click and drag the perspective tabs to the left, which we already did, so you can see all of both tabs. The program ran through the C environment initialization routine in the runtime support library and got all the way to where it stopped at the main function in main.c. In step 9, the basic buttons that control the debug environment are located in the top of the debug pane. If you ever accidentally close this pane, your debug controls will vanish. They can be brought back by clicking View, Debug on the menu bar. If you hover over each of those buttons, you'll see its function. The Resume button, the Terminate All button, there's a Suspend button, there's Step Into, Step Out of, all of the different controls that you'd normally expect to see for debugging code. So in step 10, at this point, your code should be at the beginning of main. Look for a small blue arrow left of the opening brace of main in the middle window. That's your code window. This blue arrow indicates where the program counter is pointing. Click the resume button to run the code. On your board, you should notice that the red and green LEDs are toggling as they did before. And ours are toggling. Go ahead and click suspend. The code should stop somewhere in the pre-application mode function. That's the mode before we would have clicked the button on the board. In step 12, single step, which is the step into button, step into the code once and it will enter the timer interrupt service routine for toggling the LEDs. Single step a few more times. You can also press the F key if you like. And notice that the red and green LEDs will start alternating on and off. In step 13, go ahead and click the Reset CPU button. It looks like a chip with a couple of hands on it. And you should be back to the beginning of main. In step 14, the Terminate button will terminate the active debug session, close the debugger, and return Code Composer to the CCS Edit view. Go ahead and click the Terminate button now. As soon as we return back to the Edit view, close the project by right-clicking on Temperature Sense Demo in the Project Explorer window and select Close Project. The MSP430 LaunchPad kit includes an optional 32 kHz clock crystal that can be soldered onto the board. The board as is allows signal lines X in and X out to be used as multi-purpose I/Os. Once the crystal is soldered in place, those lines will be a digital frequency input. Please note that this is a delicate procedure since you'll be soldering a very small surface mount device with leads that are 0.5 millimeter apart on the LaunchPad. The crystal was intentionally not pre-soldered on the board because these devices have a very low number of general purpose I/O pins available. This gives you, the user, more flexibility when it comes to functionality of the board directly out of the box. It should be noted that there are two 0 ohm resistors on the board, R28 and 29, that extend the crystal lead pins to the single inline breakout connector. In the case of oscillator signal distortion, which leads to a fault indication, those can be used to disconnect the J2 from the oscillating lines. So the procedure to solder the crystal oscillator to the LaunchPad is there in step 1. Go ahead and solder the included clock crystal to the LaunchPad board. The crystal leads provide the orientation. They're already bent down in such a way that only one position mates it up for the soldering. Be careful not to bridge the pads. The small size makes it extremely difficult to manage and move the crystal around efficiently, so you may want to use some tweezers and some tape to arrange it on the board. Be sure the leads make contact with the pads. I used a magnifying device to ensure it was lined up correctly. Solder the leads to the two small pads and the opposite end of the leads to the larger pad. There is a link shown below how one of our folks that was using the board went ahead and soldered the crystal to their board. You can go ahead and look at that. So what we need to do next is verify that the crystal is operational. So in step 2, go ahead and create a new project by clicking on File, New, CCS Project. And then we'll make the selections that are shown in the workbook. The project name will be Verify under Crystal. Again, make sure not to use the default location by unchecking the box there. The location is going to be MSP430 LaunchPad, Labs, Lab 2, Project-VC. That's Verify Crystal. The family and variant type should come up already. It doesn't matter that you type the variant in the left-hand window as long as the right-hand one is properly selected. Make sure you have empty project selected and save finish. Then we can click on, once the process completes and brings up the main.c file for editing, go ahead and click File, Open File, and navigate to MSP430 LaunchPad, Labs, Lab 2, Files. Inside there you'll see the verify under crystal.txt file. Copy and paste the contents of that into main.c, making sure that you erase all the previous contents of main.c. Then you can go ahead and close that text file since we're not going to need it. Again, like in the previous code, if you're using the 2231, find the include statement at the top that currently says MSP430 G2553 and change it to yours for the 2231. When you're done, go ahead and save your changes. In step 5, click the debug button. After a few seconds, the CCS debug view should open. The program will load automatically, and you should now be at the start of main. Once the Code Composer debug view opens up and you're at the start of main, go ahead and run the code. If the crystal's installed correctly, the red LED on the board should blink slowly, and it is. If it blinks quickly, you've probably either failed to get a good connection between the crystal lead and the pad, or you've created a solder bridge and shorted the leads. A good magnifying glass and a sharp soldering iron will help you find the problem. In step 7, go ahead and terminate the active debug session using the terminate button. This will close the debugger and return Code Composer to the CCS edit view. Then go ahead and close the project by right-clicking on Verify Crystal in the Project Explorer pane and select Close Project.